minus this value equals 0. Do you remember how can I solve this one? Yeah? Minus b plus or minus square root b square minus 4a c divided by 2a. I think we will have two values. One of them will be rejected, one will be accepted. Anyway, 60 square plus 4 times 869.63 square root
I didn't get
Dr.
869.
no.
I think you forgot to multiply 0.75 times.
Really? Yeah.
Yeah.
All right. 220 times 1000 divided by 0.75 times 252. Yeah.
1159.8.
This value will be 1159.51. So this term 1151. This term 1159.51. Time 4 plus 60 square root this value minus 60 divide 8. Your depth will be 11.1 inch. I think the second one or the second solution will be negative. I cannot accept negative depth. So depth, integer number, even number will be 12 inch. That means your total thickness of your footing will be 12 plus 4 inch equals 16 inch. Remember this equation to solve for D. If your column is circular column, D. Once you get your D, go ahead and add the cover to get your total thickness HF. Make sure your number will be integer and even number. Okay. Next step. What is the value of Q net? Q net equal Q allowable, which is your bearing capacity, 4,000 minus HF 16 inch time gamma concrete 150 minus gamma soil. It's not given. Gamma soil, we can assume it should be given. Soil will be lighter than concrete, so we can assume it 120 pound per cubic feet. Gamma soil, 120.
Is there tables for gamma?
Yeah. We have a table. If your soil is sand, your gamma equal number. If your soil is clay, your gamma equal number. Or it should be given in the soil mechanic report with bearing capacity. All of this stuff you will learn it about soil mechanics next semester with Dr. O. But be sure about your unit. This unit pound per square feet. This one in inch. Wow. This one in pound per cubic feet. This one pound per cubic feet. We have something wrong here. Everything in pound, everything in feet, except 16. So we have to divide this one by 12. Your unit will be something 30 times 12 divide 12. 30 times 16 divide 12 minus 4,000. Your value will be 3,960 pound per square foot.
You said Q allowable is
The bearing capacity.
pound per foot square? Yeah.
Yeah, pound per square feet.
Okay, that's why.
That one cubic feet. That one cubic feet, if you multiply this cubic feet by feet, it will be square feet. Okay. What is the area required of footing? Your area required equal P, your unfactored load or surface load 150. Remember, it's kept. Divided by Q net 3,960. But remember, this one pound per square feet. This one in kept, this one in pound. So I have to multiply this one by 1,000. I can tell you what is the area required in feet square. 150 times 1,000 divide 3,960. We are looking for 37.88 square feet. Your area of footing,
15.
this area must be 37.88 or greater. Most of the time, the shape of your footing looks like the shape of your column. What do you mean? If your column is rectangular column, your footing will be rectangular footing. If your column is a square column, your footing will be square footing. If your column is circular column, we recommend to get circular footing, but we cannot construct it, so we recommend square footing. So I believe your column 50 times 50 is a square, so I will choose square footing for this area. So I recommend B time B will be, what do you think? 6 times 6? No? 6 times 6 is 36, smaller than the area required. Okay, what do you think?
8
Why 8? Why say 6.5?
or 6.5.
What's the problem? 6.5 times 6.5 feet. So 6.5 times 6.5 equal 42. We can decrease it maybe 6.25. I cannot say 6.5 is wrong, but to be more economical, 6.25 times 6.25, yeah, 39. You can make it 6.1 times 6.1. Let's try. 37.2. No. 0.2. You can get the square root of this one. That's all.
Yeah. 18.
Okay, 38. I think this one will be better. I need, if you multiply your selected dimension, you have to get this value or greater. 36.2 times 6.2 equal 38.4, which is greater than the area required. So now I can tell you, hey, your total thickness of this footing equals 16 inch. This dimension will be 6.2 feet times 6.2 feet. All of these calculations just to determine what is the dimension of your footing. Go ahead and determine how much steel reinforcement we need. How much steel reinforcement is required. So keep going. What is the LM? Here is your footing plane. Here is your column. Centroid of column is the centroid of your footing. This length 6.2 feet. This length 6.2 feet. This length 15 inch. This length 15 inch. Any question so far? To determine your bending moment, okay, go ahead at this face of your column. We will assume this part of footing is fixed here. Your soil will apply pressure on this part of footing. So we expect pressure coming from the soil to the part of the footing, which you call Q ultimate. Can you tell me what is the value of Q ultimate? Yeah, Q ultimate equal this one. Your P ultimate divided by area of footing. What is the value of P ultimate? Value of P ultimate 220 divided by your area of footing 6.2, the actual area, times 6.2. Your pressure will be 5.7. Please be careful about your unit. Your load in kip, your area in feet square. That's right. Can you tell me what is this length? SLM?
Yes.
Yeah. Go ahead. If you divide 6.2 by 2, you are talking about this total distance. That's right. If you divide 15 inch by 2, you are talking about this little distance. If you subtract, you are talking about LM, but you have a little mistake.
Inch.
This one in feet, this one in inch. So I need to convert 15 first to inch, to feet. So you have to divide it by 12. Anyway, your distance from the face of the column to the edge of footing equal 6.2 divided 2 minus 15 divide 12 first divide 2. Your value will be 2.475 feet. Go ahead and calculate your moment. Go ahead and calculate your bending moment. Your moment equal your Q ultimate 5.7 times this length square divide 2. If you didn't multiply here by P, so I will assume this moment only for unit length for 1 feet. That means your steel reinforcement for each 1 feet. Each 1 feet I need to put something. Each 1 feet I need to put something. I recommend this one. I like. So remove B from here and remove B from here. I don't like this. Anyway, your bending moment will be this value square divide 2 times 5.7. Your bending moment will be 17.5 kb foot. I think once you get your bending moment, go ahead and design your M ultimate 17.5 time 12,000 divided by Phi 0.9 D square D. What is the value of D?
6.1.
No, your D 12 inch.
Where did we get 12,000?
I'm sorry?
Where did we get 12,000?
Good question. Your 17.5, go back to your unit, it's kb foot.
Oh,
I would like to convert everything to pound and inch. From kb to pound, 1,000. From feet to inch, 12. So we have 12,000. Go ahead and get your Rn. Once you get Rn, go ahead and put F yield, Fc prime, Rn, Fc prime to get your rho required. convert your rope required equal area steel required divided by depth time 1. Your depth 12 inch, your row required, you got it, you can get your area steel required. This area steel for each unit length, because I removed this B and I removed this B. If you keep this B and this B, your area steel will be for the total length of your footing. Both of them work. A lot of calculations. This is only for one footing. And maybe if you design the second footing, we have overlaps, we need to remove everything and design a new footing for combined footing. But we need to understand what is the concept behind. So, the concept of design of footing, we need to determine how much area required, your dimension, how much thickness, how much steel reinforcement in both directions. I will continue next time and I will show you how to use the software to design.